Okay, lesson 44. So chain rule, an alternate definition of a derivative, and a symmetric derivative. Okay, we keep going back and forth between a derivative and an integral, and that's okay. Okay, but this is something else to apply for a derivative. Okay, not integrals. We're not applying it there yet. Okay, so when we think about the chain rule, okay, what we're looking at is if you have a function machine. They talk about these where it's like you have something, you put it in, the machine does something to it, and it puts something out. It's really like a rule, okay? They call it a function machine in a lot of math texts, but it's saying what the rule is, okay? So if you have two function machines or two rules, okay, the first is showing that you multiply any input by 3. Okay, so what it says is you have your value and you put it into this function machine, okay, and it's taking that input and it's multiplying it by 3. Okay, then what comes out of that is 3 times what you put in. So we'll call this input value x. Okay, then what comes out is 3 times that. So we'll call this now u. Okay, then the second function machine takes its input and multiplies it by 2. Okay, so if the first one multiplies by 3, then I get an output value. And then I put that output value into the second function machine, and I multiply it by its input. Then I get 2 times this input, which ends up being 6 times my original input value, right? Because I took my input multiplied by 3, then I took that and multiplied it by 2, and I got 6 times the original value, okay? So looking at it as a graph, okay, 3 times an input looks like this. So here's 1, this would be 3, okay? So what this is saying is that this is 3 times the input, which is u. Then I go along and I say, okay, y is going to be 2 times u, which is 2 times 3x, or 6x. So it looks like this now. Okay? So when we look at that, the rate of change of u with respect to x is the slope of this graph. Okay, which happens to be 3. The rate of change of y with respect to u is the slope of this graph. Okay, so respect to u is going to be the slope, which is 2. Okay, if x changes by 1 unit, u will change by 3 units. But if u changes by 3 units, then y will change by 3 times 2, or 6 units. Okay? So then what that tells us is that the change of 1 unit in x causes y to change by 6 units. So then the rate of change with respect to x is going to be 6 over here, not just 2. Okay, because it's the product of the 2 rates of change. So we use linear functions just because they're basic and they're something we all understand, okay? But this rule is true for any 2 functions if their derivatives exist. So that rule is called the chain rule. okay? The nuance that it contains is kind of not really obvious, but it states that the derivative of a composite function equals the product of the slope of the second evaluated at u times the slope of the first. Okay, so if we use Lebanese notation, it's pretty easy. It's easier to remember. So what the chain rule says is that the derivative of y with respect to x is the derivative of y with respect to u crossed with the derivative of u with respect to x. Okay, so the first part of the product is the rate of change of the second function. And the second part is the rate of change of the first. Okay, so that's our chain rule. So we can take this product and extend it to define the derivative of any number of functions linked together in this fashion. Okay, so if x is a function of s is a function of t, then it can keep going. Okay, so then the derivative of y with respect to t is the derivative of y with respect to u times the derivative of u with respect to x times the derivative of x with respect to s times the derivative of s with respect to t. Right, because if you start canceling, you have these cancel, and you get dy dt. Okay, so each new dependence adds another link to your chain. That's why it's called a chain rule. Like, this looks like a chain, so if you add another part to it, it adds another chain to the rule. So it allows us to check by canceling out, right? Like we just saw, we could check that it works because denominator cancels the numerator. Denominator cancels the numerator. Denominator cancels the numerator until you're left with what you want. Okay? You can also state it using a modern variant, so using the functions. Okay? So if h of x is f of g of x, right? This is a composite function. It's saying that f is evaluated at another function, not a number. So this you went over in algebra, this part. Okay? Then h prime is defined as f prime at g of x times g of x, or times g prime of x. Okay? All right, so let's see how we are going to actually use the chain rule rather than all of these like letters. Okay? So what it says is we're going to let y equal the sine of u and u equal 5x cubed. Okay, so really, if we put them together, we're saying y equals the sine of 5x cubed. Okay, so we want to find dy dx. So the chain rule is like when you have a function evaluated as a function. So if sine is a function, we're evaluating it at this function 5x cubed. Okay, so then the chain rule tells us that it's the derivative of the function y with respect to u times the derivative of u with respect to x. Okay, that's what the chain rule is telling us. So then dy dx equals the derivative of dy dx, or dy du. So we're finding the derivative of sine of u. Derivative of sine u with respect to u. Okay, so what's the derivative of sine? The derivative of sine is cosine. So we get cosine of u times the derivative of u with respect to x. So du dx is the derivative of 5x cubed over dx. Okay, so the derivative of 5x cubed is 5 times 3 is 15x squared. Okay, but then you want it with respect to x, so you replace your u with what u is equal to. So dy dx equals 15x squared times the cosine of 5x cubed. This is kind of replacing u substitution, okay, where we took our function, substituted it for u, then you would have found du and multiply. Okay, it's a shortcut for that. So chain rule is take the derivative of each one respectively and then put them together and write them in terms of the same variable. Okay, that's a chain rule. Derivative, we are familiar with multiple forms of derivatives. Okay, we are familiar with derivative as a limit. Okay, so we're saying that f prime of x is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Then we said this delta x can get confusing because if we write a lot of them out, we don't know which is what. So then we said that the derivative we're going to define as the limit as h approaches 0 of f of x plus h minus f of x over h. These mean the exact same thing. Okay? So we're using a delta x or an h. They're meaning the same thing. So as an alternative definition, we're using the value of the function at some constant and at x. And so then we're going to say that f prime of x equals the limit as x approaches a. So x approaches that number of f of x minus f of a over x minus a. Okay, this f of x minus f of a is just the change in your y values, and this is just the change in your x values. So it's just a different way to express the same statement that we have here. Rise over run. Derivative is the slope of your equation. Okay? One other form of a derivative that's worth noting, okay, is something called symmetric form. Of the derivative, or the symmetric derivative. Okay, and what it says is that if f of x is your function, okay, then the derivative can be found by saying that f prime of x is the limit as h approaches 0 of the function at x plus h minus the function at x minus h over 2h. Okay? So just different ways of saying the exact same thing. Okay? All right, 2 examples, and then that's lesson 44. So using these new definitions. Okay. So we're going to use the symmetric definition for f of x equals negative 3x plus 2. We want to find the derivative using the symmetric definition. Okay, so the symmetric definition tells us that f prime of x is going to be the limit as x approaches, or as h approaches 0 of f of x plus h minus f of x minus h over 2 times h. Some of these definitions just help us to eliminate 0 in the denominator, okay? So f prime of x is the limit as x approaches 0 of this function evaluated at x plus h. So negative 3 times x plus h plus 2 minus negative 3 times x minus h plus 2 over 2h. Then we have to simplify this, right? We need h out of the denominator because we don't want to divide by 0. We can't. So we get negative 3x minus 3h plus 2 plus 3x plus 3h, no, minus 3h, yeah, because this would be a negative 3x plus 3h and then the negative. So minus 3h minus 2 all over 2h. Okay, simplify again. That is the limit as h approaches 0 of, well, negative 3x plus 3x cancels. 2 minus 2 cancels. So you are left with minus 6h over 2h, which is nice because now your h's cancel and you're left with the limit as h approaches 0. I'm still seeing people miss this limit, right? At this point, they just cancel out the limit and they get negative 6h over 2h, okay? Not quite what we're looking for. So the h's cancel, so we get the limit of negative 3, which is negative 3. So the derivative of negative 3x plus 2 using the symmetric definition is negative 3. Okay? All right. Then let's use this alternative, the x minus a. So we're going to find f prime of a. Where f of x is x squared plus 1. Okay? So what this tells us is, using this definition, f prime of a is going to be the limit as x approaches a of f of x minus f of a divided by x minus a. Okay, that's the definition. So what you do is you substitute in f of x. So it's the limit as x approaches a of x squared plus 1 minus the function evaluated at a. So it's a squared plus 1 divided by x minus a. Okay? Then you simplify. So we get the limit as x approaches a of x squared plus 1 minus a squared minus 1, because we have to distribute that negative, over x minus a. That's the limit as x approaches a of the minus 1 plus 1 cancels. So we get x squared minus a squared over x minus a. We still have x minus a in the denominator, but the numerator is difference of 2 squares. Okay, so we're going to factor that. So it's the limit as x approaches a of x plus a times x minus a over x minus a, right? That's how you factor the difference of 2 squares. So x minus a's cancel, and you get the limit as x approaches a of x plus a, right? A is not, 0 is no longer in the denominator, so now you can just substitute in a for x, and we get that this is a plus a, which is 2a. That would be the derivative of the function at a. All right. So chain rule and just other definitions for derivatives, okay? That is lesson 44. So technically, this is the stuff that ends before we go on spring break, right? You're off for the next 2 weeks, so you just need to do 43 and 44 by the time spring break ends, okay? So that's the week of the 20th, I believe, okay? So then we'll take it from there. So 43 and 44 are due after spring break.